bcrypt and jsonwebtoken are the only two packages this API needs for real auth, and most from-scratch tutorials still get both wrong. Not a login as a service. Not a framework plugin. Two small, boring libraries, wired correctly. Here's what we're building. A bare Express API with a working signup route, a login route, and one protected route that only opens for a valid token. No database magic, no ORM, just the actual mechanics. By the end, you'll know exactly why passwords get hashed instead of encrypted, and you'll see the one missing line that turns a stolen token into a permanent skeleton key. Start with a plain Express app. One file, one dependency install, Express, bcrypt, and jsonwebtoken. 3 packages, nothing else. The signup route takes an email and a password. The password never touches the database as typed. bcrypt.hash runs it through a one-way function with a random salt baked in. 10 or 12 rounds is the usual default. What gets stored is that hash, not the password. That's the whole signup route. For lines that matter, read the body, hash the password, save the user, return success. No password field in the response, ever. Login looks similar but runs the check backward. You pull the stored hash for that email, then call bcrypt.compare with the plaintext password the user just typed against that hash. bcrypt rederives the hash internally and compares. You never decrypt anything, because a proper hash can't be decrypted at all. If it matches, you don't just say, OK. You sign a token. jwt.sign takes a small payload, just the user ID, a secret key, and an expires an option. 15 minutes, an hour, a day, whatever fits the app. That token goes back to the client. Now the protected route. A tiny middleware function runs before the route handler. Read the authorization header, pull the token out, call jwt.verify with the same secret. Valid and unexpired. The request continues. Missing, malformed, or expired. It returns 401 before your route code ever runs. That one middleware function is the entire lock on every route you attach it to. First mistake, encrypting the password instead of hashing it. Encryption is reversible by design. If your database leaks, every password leaks in plain text the moment the key leaks with it. Hashing is one way on purpose. There is no key that unlocks a bcrypt hash, because there's nothing to unlock. Second mistake, and it's the sneakier one, signing a token with no expires in. Skip that option and the token is valid forever. Steal it once, and it works until you rotate the secret for every user on the system. A 15-minute token limits the blast radius of a leak to 15 minutes. A forever token limits it to nothing. One more. That secret key jwt.sign and jwt.verify both use. It goes in an environment variable, never in the code you commit. Hardcode it once, and it's in your Git history forever, even after you fix it. For a side project, an internal tool, or anything where you own the whole stack, this is maybe 40 lines of code and 0 recurring cost. You understand every line because you wrote every line. The moment you need social login, multi-factor auth, or you're handling data under real compliance rules, hand it to a managed provider instead. You're paying for edge cases you don't want to own, not for laziness. The trade is real money and some vendor lock-in against months of security work you'd otherwise redo yourself. The rule of thumb: roll your own until the auth requirements grow past what one file can hold. Then buy it. Would you trust hand-rolled auth in a real production app, or is a managed provider always worth the cost? Tell me which side you're on in the comments. If this made the 2 mistakes click, hit like and subscribe. It's genuinely what lets me keep building these out loud. Next up, I'm pointing a coding agent at this exact auth code and putting the entire diff on screen, everything it got right and everything it quietly broke.